audio, Boolean operation, etc., right? Digital television, equalizer and all. So these are all the blocks. So these are all the blocks are available. So if you expand, let us say audio, right? Under audio, you will be having n number of blocks, audio sink, audio source, etc. Like that, you are having n number of blocks. Similarly, so in each core block, you will having other supporting blocks. Fine. So this is your workspace. So once you open the new file, I'm just opening new file, new. Sorry, simply I can click this new one, right? So that will open you the new one. Just become untitled one. Untitled new files are opening here, right? So this is a workspace where you can simply drag and drop, right? So now let me open, let us, how to use this block. Simply you have to go to, let us say, I want to develop some kind of signal source, right? So you can go to some signaling models, right? Or simple signal source, where it is, I think. So we have to go to W waveform generator. Here you can able to see the various sources. Here I am clicking the signal source. Just if you double click it on this signal source, right? So the signal source, it will appear automatically on your workspace. So here you can able to see that now it is appearing the signal source, right? So this is a one block, the signal source block. It has the sample rate, waveform, frequency, amplitude. Again, if you double click on this, right, you will get the signal source properties, the block properties. So here, whatever you want, if you want to give a new ID also, you can give output type, what type of output type you want, whether you want complex, float, or integer, or short type of thing. So these blocks are similar to your MATLAB Simulink. So if you are worked with Simulink, you won't face any problem of using these blocks. If you have done small experiments like AM, FM, or any other low pass filter, high pass filter application using MATLAB Simulink, the similar operation only. There is no much difference of things. So like that, so this is your block. List of blocks are available on your right hand side. So just you have to click or you can drag and drop in this workspace so that it will work, right? So that is the one point I would like to say. So next, another important point is the color mapping. There is another important concept called the color mapping. So here I am just clicking the signal source, right? And I am using up arrow keys, up or down arrows. You can notice the color change at the output. This is the on your left hand side is your input, and here it is called output. The output colors are changing. Now it is in yellow. Now it is changing to blue, right? Now it is orange, right? Like that, the colors are changing. So what does it mean is you have to go to help, come to types. Here you can see the color mapping. For example, the color blue indicates that complex float 32-bit output. Or if you don't want any complex waveform like e power j omega, right? So you want only the integer waveform, right? Then you can go for normal float operation, right? Or you want like what I can say, you want a complex signal or normal signal. So accordingly, you can change this one also. So this is the color mapping, right? So accordingly, it will get changed, right? So this is the signal. So similarly, you can explore the each and every block you can do. So here I have just mentioned this PPT about the various color pattern. So what type of color you want, accordingly you can able to choose whether it's a complex signal or a real signal, right? So there is another block called throttle. There is another block called throttle block. Before getting into throttle block, I would like to say one more point. So GNU radio uses stream-based processing model, which is slightly different from your MATLAB model. Because in generally MATLAB, we will use the array-based processing, right? So it will take the signal array of vector arrays, then it will process and it will give the output. Whereas here it will consider it's a block by block. It's called a stream. So it will take and each and every block, then it will process block based module. So each block has its own independent scheduler also. So that's why we are using another block called the throttle block. So that we can limit the processing speed, and also we can make all the blocks unified to the particular sampling rate. That is the core role of the throttle. So you can able to, if you want to take any block, you can use the search button also, so that you can get. So here I'm taking the throttle. Throttle is another block, right? So here simply you have to give your ID and you can use some sampling rate. So this sampling rate, sam underscore rate, right? So it is already fixed, which is 32K. Where it is fixed, here we are having a block called variable. So in this variable, the value is already fixed for this particular block. If you want to change it also, you can change. If you want to work on very high sample rate also, you can you can change this sampling rate, and accordingly you have to define this variable. So just you can open one more block of variable, and whatever sampling rate you want also, that also you can able to define it, right? So let me open a simple uh, demo program, right? So I will open. So I have stored. So all the programs you are working, right? You will work on this GNU radio companion. It will be stored as with the extension named as .grc. GNU radio companion. Simply it is called .grc. So here I am opening the demo tutorial one. I'm just opening that file. So here the demo tutorial. So this demo tutorial is for simple waveform generation. I have made a simple module for waveform generation. So here I have mentioned a signal source. So in the signal source, I'm just double clicking, right? Something waveform also you can change if you want. Here I have mentioned it as waveform. So the frequency of 1 kilohertz and amplitude also you can fix it. You can work, right? Also the throttle block and this Qt GUI sync, right? This Qt GUI sync is the output where you can see the waveform. So this is graphical user interface, right? Where you can, it will visually, it will give you the output as a graph, similar to what we are seeing in our MATLAB, right? The same kind of output, output block, I can say. So to run this, let us save this demo one, right? So here you can able to see now I have mentioned with the yellow color. That is a real signal. So to execute this, either you can use this button, execute the flow graph. So here it is called flow graph. All your, how we can call it is MATLAB is called Simulink model we will call. Here it is called flow graph. Each work is considered as a flow graph, right? Either you can use this GNU radio, it will play the major role, so that parallelly they will get a good hands-on experience on working on Linux mode of operating system, how to set the path, how to overcome the technical glitches while deriving the path, right? How to call the dependency files doing all these operations. So there are many connected things to learn once you use the GNU radio platform, which is largely missing in the MATLAB platform. So I'm suggesting you can use GNU radio for up to PG level projects. But if you ask me, can I use GNU radio for the PhD work? I can say openly no. Don't go for GNU radio for your PhD work, because GNU radio has many limitations, because it has many defined blocks. Though you can modify the block by writing your own Python script and all, but it has many limitations, because the blocks you are seeing here in this signal space, right? Whatever GRC company, so they haven't upgraded for in the last 10 years. So whatever blocks are there, these are all existing blocks, used blocks. So there was no major changes in this one to support advanced wireless technologies. Like, okay, fine. So that is one of the major drawback I can say. But still, you can. I am strongly suggesting to go for GNU radio for experimenting with various signal processing concepts. For example, filtering, for example, higher order modulation schemes, comparing bit error rate of various modulation, working on YFDM based modules, right? You can develop FDMA, TDMA, CDMA based modules. For that kind of modules, you can use. There are many interesting sites are available, so you can use for your. You can give that link to students so that you can work on various tutorials on GNU radio. There is one guided tutorial on GNU radio in Python, right? So you can. One more thing I would like to say. So when you make any program, right? So all these blocks, sorry, when you build any modules, once you start run this module, parallelly these particular flow graph, it will be converted as a Python script. So here you can able to see the another generate the flow graph. If you hit this generate, you're able to see the Python stuff, I think. There's a file, yeah, for example, this program is stored as top block.py, because here I have mentioned the name as top block ID. In the option, I have given ID as top block, so it will be stored as top block. So once you open this top block, I think you're able to see the complete Python script also. So I'm just using with getting ideal and opening this. I'm able to see complete Python script also. So like all your flow graphs, backend it will be stored as Python libraries. So you can open. So this is a GNU radio Python flow graph which we have developed. You can able to see this one. So this is the script, right? So these are all Python libraries like import, right? Right. So all various blocks we are importing, right? So all these block modules are also programmed here. So as so all are like Python based programming modules. So you can ask students either to work on these Python libraries also, or you can ask them to build a flow graph, and you can parallelly generate your Python libraries. So then you can experiment with various algorithms, right? So some interesting tutorials here I have mentioned. So if you want to understand about introduction to SDR and GNU radio, you can use this link also. Similarly, there are some other toolbox also available for radar-based object detection, which will operate on VHF and UHF bands. So that kind of work also you can assign to student for UG and PG work. You can ask them to engage. So GNU radio is one of the interesting signal processing open source tool where you can use for implementing your SDR based modules, and also you can use this if you are using any USRP boards. Also you can connect this one, but the recently available USRP boards are not supporting GNU radio, so it will support LabVIEW based platform, right? So that's all about GNU radio tutorial. So if you want, if you want to understand more, if you need any other queries that may be related to GNU radio or related to wireless based research work or something, then you can connect with me, you can call me, or you can drop me a mail, so I will respond as early as possible. So I hope you enjoyed this session. I hope it was not boring. I hope there could be some takeaways from this talk, I guess. So requesting participants, if you want to add something, you can add also, or so you can share something. Right.
So not really, sir. Actually, good, interesting session, sir. There are more takeaways from your lecture, sir.
Fine. You can drop
Sir?
email if you want to understand more
They
deep
participants,
technical things. Yeah. So can connect.
yes,
Right. Yeah.
okay, okay, sir. If
So
I
let's
have
go
any
for a
queries,
stop
can
sharing.
ask our speaker.
Yeah.
Sir?
No. I'm just I have given stop sharing. So I'm just saying. Yeah.
Oh, okay, sir. Okay.
Yeah.
Uh, Participants, if you have any queries, can ask our speaker. Balaji sir, Dr. Balaji sir. Or you can utilize the chat box.
Chat box.
Participants, the session is going to end. So if you have any queries or doubts based on maybe your research or anything, you can ask our speaker. Chat will help regarding the queries. So I hope there is no queries or doubts regarding the session.
Fine.
Sir, very again, I thank you, sir, for a wonderful session. What you have given about the 5G new radio, and also given a demonstration on the GNU radio. So I also thought that the GNU radio is going to work only in Linux or Linux OS only. But later, if you say that the later version is going to have in Windows, also we can use it likewise. It's a very useful information, sir.
Thank you.
So the participants also gained more knowledge in the session, sir. So when going on the session, I have invited some students also, those interested in IoT. Also, I have invited some students. They also came in the middle, sir, and they also told the feedback is very good, informative session, likewise, sir. So I get the positive feedback for this, sir.
Nice. Fine.
So again, thank you, sir. And I call upon Mrs. Jeevita ma'am to give you a vote of thanks to our chief speaker.
So very good afternoon to all. So today we had a great experience and learned many things from our speaker. Thank you, sir. And I thank our executive director, sir, principal, sir, HOD, sir, faculties for their support. Once again, thank you all. Thank you, sir.
Thank you. Thanks a lot. Thank you.
And especially Dr. C. Karthikeni madam to suggest you, sir, for this session.
Oh, that's nice.
I have to thank her.
Thank you, thank you, thank you, thank you. Yeah, fine. Thanks a lot. Yeah.
Thank you, sir. Participants, the feedback link has been pasted in the chat box. So those who are in the session work, and again you can sharply join at 2 p.m. So the afternoon session will be of the theoretical as well as the practical order classes like a morning session. So on a new demo of a project, a new project demo has been showing up the last end of this today's session by Mr. K. Mahendran sir. So it will be of more interesting, I think. Join sharply again at 2 p.m. Before that, please fill the feedback form link. So it is pasted in the chat box. So again, I will give the link. So please fill the link before 12:20 p.m. Thank you all.